This is the second in a series of presentations on seasonal affective disorder, winter SAD and the environment. What causes winter SAD? There is no definitive answer, but for the most part, it's all about daylight and darkness. Two theories about the causes of winter SAD are the photoperiod and phase shift theories. Photoperiod theory suggests that winter SAD is caused by seasonal changes in the length of daylight, which is longer in summer and shorter in winter. The phase shift theory focuses on the effects of light on our circadian rhythms, in particular the 24-hour sleep-wake cycle. In this hypothesis, winter SAD is said to be similar to traveling east or west across many time zones. If you travel from California to New York, for instance, you lose 3 hours according to your body's clock. As a result, when the alarm rings at 8 a.m. the next morning, you feel tired. For you, it's still 5 a.m. You are out of sync. Studies have shown thus far that winter SAD is not correlated to weather, such as temperature, barometric pressure, rainfall, or snowfall. However, we do know that constant dim light or darkness can throw our bodies out of sync. Winter SAD is really more about latitude than weather. There are 90 degrees of latitude north of the equator and 90 degrees of latitude south of the equator. Not much is known about the prevalence of winter SAD in the southern hemisphere, but we do know that at the equator, where there are nearly equal periods of daylight and darkness throughout the year, 12 hours each, winter SAD is not reported. We also know that winter SAD increases with latitude. But as we know from a number of research studies, this is only true to a point. In Fairbanks, Alaska, for example, at 65 degrees north latitude and Nashua, New Hampshire at 42 degrees north latitude, nearly the same percentage of cases with SAD in a sample population have been reported. In contrast, at 64 degrees latitude in Reykjavik, Iceland, and at the same latitude at a location in central Siberia, researchers have found a wide variation in the occurrence of SAD by more than 12 percentage points. And all at 59 degrees latitude, Stockholm, Sweden, Helsinki, Finland, and Oslo, Norway diverge widely in the prevalence of winter SAD in sample populations. Clearly, factors other than latitude contribute to winter SAD. These may include weather, cloud cover, adaptations of indigenous populations, diet, or other factors as yet undetermined. Let's get back to a discussion of daylight and darkness and how it relates to winter SAD. There are 4 terms you need to know in understanding winter SAD. We've already touched on a couple of these: circadian rhythm, photoperiod and photoperiodism, circannual rhythm, and biological clocks. Circadian is a Latin word meaning about a day. Circadian rhythm is simply the daily cycle of activities based on a 24-hour interval, such as sleep cycles of animals or the opening and closing of flowers. Photoperiod is a circadian rhythm that we all know. It's the 24-hour cycle of daylight and darkness. We call this environmental time. Photoperiodism is the biological and behavioral response of living organisms to photoperiod. Photoperiod, of course, changes throughout the year as the Earth revolves around the Sun. This is because the Earth's axis is not straight up and down, but at a slight angle, 23 degrees. As the Earth revolves around the Sun, the length of daylight varies depending on latitude. During part of its revolution, the Earth's northern hemisphere tips toward the Sun, so we have summer, while the southern hemisphere experiences winter. Likewise, at other times of the year, the northern hemisphere tips away from the Sun, and so there is winter, with summer in the southern hemisphere. Based on planetary cycles, living organisms experience circannual rhythms, or annual rhythms, such as mating behaviors, hibernation, bird migrations, growth patterns, such as tree rings, or bud dormancy. These are all biological responses to the changing photoperiod, that is, the changing seasons, and for some, unfortunately, winter SAD is among those responses. So how do we get out of sync? If we're not jetting across time zones, why does this happen? Why is it that people with winter SAD don't adapt well to seasonal change? The reasons are complex, but they have a lot to do with the problem of synchrony. Environmental time with its daylight and darkness, its weather patterns and planetary movements is not our only timekeeper. All living organisms also keep biological time by way of an internal mechanism or biological master clock. When our biological clock is running a little fast or a little slow, we get out of sync with environmental time. This is when the problem starts. Thanks for listening to this presentation. Other presentations on seasonal affective disorder can be accessed from this webpage, including seasonal affective disorder, It's Not Just the Winter Blues, SAD and Our Biological Clocks, and treatments for winter SAD with a focus on light therapy.